Tak jo, tak začneme. Asi teďka už je správnější čas. Takže Jules Recin is an architect and designer from Belgium. He studied architecture in Belgium, Chile, and at the AA in London. His work is internationally acclaimed thanks to awards, lectures, and exhibitions at major institutions such as the Centre Pompidou. Jules Recin is also known for his work at the Bartlett School of Architecture. And then, no.
Super, thank you so much. Thank you, guys. So I actually want to kick off this talk by thanking you for inviting me here. I arrived yesterday. I already had a really good time exploring a little bit of Brno. I was given many beers as a welcome, which was very nice. And it's really amazing, I think, like to be in a school like this. Like I'm a strong believer that actually the most interesting things in architecture usually happen, you know, not in places like London per se, but actually maybe in small schools like yours or a bunch of other schools that I visited over the past few months. And I can really feel the kind of energy in the school, you know, with the giraffes and the crazy circus, and it's so cool. Like it's really fantastic. So that made me really excited this morning when I woke up to kind of, you know, think about what I was going to talk about with you. And also because we have quite a bit of time, so this is like, I have like 300 slides, so we have to see how far we get and how boring it gets. And the idea is like, usually when I do a talk, you know, I put up like my talk hat and I just, you know, give an argument and I try to convince everyone that I'm right and that this is the way to go. And it's like a very polished argument. This lecture is not like that. Like usually I don't present what I will do today. It's going to be a bit more maybe, yeah, talking a little bit about how I started my practice or what I'm thinking. It's a bit like psychoanalytical as well. So it's going to give you a bit like, it's a bit of an experiment, but it's going to give you maybe a bit more than a normal talk that I do. Right, so let's get started. So there's kind of, let's start with the title actually. Yeah, so the title is about parts that precede buildings, which I think it's inspired by Murakami, who's a Japanese writer. I love titles. I think this title sounds a bit like a Murakami book, like parts that precede buildings. It's weird, right? Like how is that possible that there are small bits and pieces already before a building exists? And then the subtitle is Architecture in Large Quantities, which I think will become clear what that means. And the talk is very badly structured in 4 parts. So we'll first talk a little bit about, I'm going to try to give you like a rough idea what I mean with parts that precede buildings and how that could become a form of practice. Then we'll talk a little bit how I'm approaching that as an architect, like what is actually research as an architect. And that's also based on some conversations that I had yesterday about, you know, the notion of research, what is actually like research in architecture. Then I'll talk about spaghettis to automated platforms. And then I'll have some thoughts that I actually want to discuss with you afterwards. And the work that I will show is from 3 different modes of practice. So one is from my architectural practice, which I've creatively given my own name. The second one is from a new company that I started during COVID, which is called AUR. You need to pronounce it as AUR, A-U-A-R, which stands for Automated Architecture. And that's actually a tech company. It's not an architecture company, but it's engaged in architecture. And then underlying that, I will show some work of my students at UCL, at the Bartlett School of Architecture. Okay, so parts that precede buildings. I'm not going to read this, like this is the kind of the hypothesis in a way of the work. So you could say that the work, what it tries to do is to, when I started, is to develop a really different way about how we could think about this idea of like the digital in architecture. Because when I was a student, everything, you know, everyone, you know, I was a big fan of like the work of Zaha Hadid and Greg Lynn and all these guys from the 90s, right? Which is in the meantime almost 30 years ago. And somehow we still associate kind of the idea that if we work with computers that we have to do really funky forms and fluid shapes, and we think that, you know, these old guys who are now in their 60s or 70s, that they are, you know, the new thing in architecture. And the idea is to, it was not only my idea, but with a group of people, that we really try to reset an agenda for what we should do with computers and robots in architecture. And that's based on the idea of automation. I will talk a little bit more about that, why I use that term. And essentially what we're proposing is that we could rethink a new paradigm that is based on the digital distribution of discrete parts, which again, that sounds kind of mysterious right now, but we'll unpack that. And the exciting thing in that is that it allows us to address a range of questions as kind of a consequence of this distribution. So I will talk both about technical knowledge, logic, so both about how you build buildings, how you write code, robots, etc., but also about architectural qualities and also about socioeconomic and political issues that are associated with this. And if you do all of that together, in a way you are working on rewiring what I call the core of architecture. And I think that's maybe the first hint at kind of how I operate. I'm quite ambitious, and I'm not interested in small things. So I like kind of blunt, really big ideas. And I think sometimes by thinking really bluntly about things, you can kind of reveal a lot. Right, so this is the context which I just described. Like that's an image. If you Google kind of digital architecture, you get all of this stuff, which was created in a way in a world that does no longer exist today. That's a world that was before the financial crisis, a world where the economy was supposedly going great, where there was no climate change, there was no COVID, there was no Russia, and we were all building these funky museums in Dubai and in China, right? And the result of that work is that, this was exciting and optimistic, and, I was very excited by that as a student. But at the same time, that work, I strongly believe, this attitude and the kind of underlying, absence of politics and absence of a social agenda and absence of the manifold of crises that we are confronted with today means that this work for me is outdated. Don't do this, please. And it's interesting to kind of, try to think what people were looking for, right? What they were thinking about. So essentially, one of the very first architects who got their hands on a computer, this incredible machine, right, that was about to kind of change the world, he decided that the first thing you should do with it is make a fish. Right? Today, that's interesting, right? I mean, why would we make fish today if you have a computer? But essentially, he was excited, Frank Gehry, he's called, by the possibility that you could again make a complex shape, right? But the thinking is very much based on that idea of like a complex, kind of impossible shape that then you could create with computers. But as I mentioned today, maybe if we have our hands on a computer or on robots, maybe we can ask other questions. Maybe it's not about how to make a fish or a crocodile. Maybe, I strongly believe that this statement by the United Nations is maybe a really important context for us as architects. And I would even like kind of try to do this as a provocation to say that anything that we should be doing today should be read in this context. Because we need to build 2 billion new homes, and we need to build them in such a way that we don't destroy the planet, right? And as an update, it's good news for architects. We have absolutely no idea how to do this. And it's also a strange time because architecture is a super strange moment today. Like there has never been as much good architecture as today. Like I have the little title here, it's never been this good. And honestly, it's never been. There have never been this many incredibly good architectural practices in the world. Like it's just an endless, like if I go to a bookshop, I'm just buying all of this stuff, right? It's all good, it's all beautiful, it's all creative, it's all interesting, and it's all irrelevant. None of this good architecture answers any of these questions. So we have never had as much good architecture that has been as irrelevant and that has been made for as few people as today, right? So it's never been this good, and it's never been for this few people. Like if you count together all of these beautiful El Croquis, maybe there's 400 people living in this work, right? What about everyone else? Like, shouldn't we think about that as well? Another context for my work, a part of this kind of, this kind of provocations is also like a technical reality that like architecture is in a kind of a difficult position. This is OMA at the 2014 Biennale, where they're kind of showing this technical reality of architecture today, that in a way we have lost as architects the kind of the power to make a lot of decisions. Like we've kind of handed over a lot of our profession to other people. And you see this kind of the difference between this world above the suspended ceiling and then the suspended ceiling. And the work is also engaged in a way you could say with maybe some of the kind of most heroic and most tragic histories of architecture, which is these guys here, for example. These are architects that really tried to do kind of what I'm doing today. They all failed, by the way, so that's also a heads up. So they're architects that tried to kind of tackle these questions about how we could reset architecture, how we could question the way that it's built, and they were thinking about, you know, entirely kind of starting from scratch and beginning again. The work is also engaged with this notion of automation, which I think is beautifully present in this image by Andreas Gursky of the Amazon warehouse. So automation is again something that might sound very abstract to you, like you might think this is automation is like, you know, cars, robots building cars in factories somewhere. Not interesting, but that's actually not true. Like automation is something that is present in our daily life. Every time, you know, you order something on Amazon, every time you go on a dating app, every time you use Google Maps, anything is decided kind of by this really interesting and weird logics of automation. And so automation is concerned, you know, both with getting tomatoes to your house, as sorting out elections or whatever, right? And the kind of, I think this image shows kind of this aesthetics of automation, which is all about essentially a project of logistics, a project of how you distribute and organize parts, which is what I mentioned before. It's also, my work is also strongly engaged with this world, which is a really strange world that is also quite new to me, but which I entered 2 years ago, which is the world of tech. There's a whole new field emerging, which is called construction tech or prop tech. So all these companies are trying to solve that question of how we're going to build 2 billion homes. They're also doing that mainly to make a lot of money of these 2 billion homes. And they're also, in one way or another, engaged in architecture. And then the work is, lastly, also engaged with theories. So in what I'm talking about today, there's a lot of weird theories and weird books that I'm reading. You can make a picture of this, so then you have the book list. So this goes from anything, you know, talking about automation to philosophical ideas about ecology or feminism or all kinds of different topics. Should I put it back? Right. Cool. So now in detail. So we're going to talk about 3 topics, 3 positions in a way. So one is architectural, one is technical, and then one is political. So first, the kind of the architectural possibility, and that's really, I mean, in a way you could say that's how it started, right? Like when I started my work, I was not kind of aware necessarily about everything. Like a lot of, when you start something, you only learn what you're doing after a while, and then you need to look back and reflect and post-rationalize. But you could say that it started kind of with the question around what would it be possible to think about an architecture that starts with parts, that doesn't know about the whole building, and what would be the consequences of that? And that's like an optimistic question. Like, could we kind of rethink a new architectural paradigm that is not modernist, that is not digital, which I call continuous, the kind of the paradigm of the 90s. But could we think about parts in a digital way, a little bit like pixels or voxels? And what would be the consequences of this on an architectural level? Like, is it possible? The world today is defined by this guy, which is Le Corbusier, his Maison Domino. Right? That's a model that is unbeatable. It's so stupid and so smart at the same time that you cannot beat it. That's also like generally the qualities of architecture. You cannot outsmart architecture. Architecture is a very stupid and blunt profession. If you try to be too smart, you will lose the battle. That's also why I should never do a PhD in architecture, because it doesn't help. I'm doing a PhD in architecture, by the way. Yeah, so you need to find, like, it's beautiful, right? It's smart and stupid at the same time, which are really good qualities in architecture. And that's a little bit this debate. I mean, I'm not going to go like too deep into that, but essentially, if you look at kind of, like, this is more a critique towards what we understand, first of all, as digital. Like, we as architects somehow always associate digital with kind of complex forms. That's really kind of intuitively what we think about. But actually, it's very funny because actually these forms are inherently analog. Because if you look at the meaning of analog, analog means there are no parts. These forms have no parts. They consist basically of parts that are always derived from the whole. So that's an analog signal. It's interpolation. It's like a watch. Whereas a digital signal essentially means that it consists out of bits. It consists out of parts. So the word digital is inherently related to the idea of discrete units or parts. Which is, again, really hilarious that in architecture we never came up with that, right? That we never kind of understood this. And actually you can apply that kind of thinking to architecture. Like, we have 2 buildings here, and you could say one is continuous or analog, and one is discrete or digital, although both of them don't involve computers. So that's Felix Candela on the left, which is a building with no parts, right? It has one part, and that part is the building. It's a continuous concrete shell, and that's basically what the digital was based on, right? On the kind of recreation of this model. There's a building on the. Did I confuse left and right just now? Yeah, right. Okay, I always do that. Okay, so whereas the building on the right, actually by Van Eyck, is a building that is discrete. It consists of parts, and you could imagine that it can keep growing or shrinking, and it could appear in many forms in many places. Maybe it's going too far to say that it's digital discrete. That's another debate, because it actually has hierarchies and it's based on a grid and it's very modernist. But at the same time, it's definitely, you could definitely say it's discrete. This is a more kind of easy version to understand. So if your parents gave you toothpaste to play with as a child, and they told you extrude little buildings with the toothpaste, right? You squeeze the toothpaste and you create structures. Then you were doing continuous buildings, right? There were no parts in your childhood. If your parents, like most parents, gave you Lego blocks to play with, you were actually engaged in the discrete and digital world. So Lego blocks are digital units. They have precise connection possibilities. They're circular. They can always be reassembled. I don't think anyone's parents gave you toothpaste, right? But maybe clay or something. So this machine that's a robot. A robot is a digital machine, but the thing that it's building is analog, right? It's doing an analog action by extruding clay. This robot is the same. You would think, no, this robot is putting bricks. Bricks are discrete. So this is not analog. This is actually also analog, because the bricks, unlike Legos, can rotate in any direction. They're connected with glue. And in that sense, they kind of are the same as clay, as particles of clay that you deposit. Very confusing. This is discrete. This is a building that consists of Lego-like pieces that are continuously repeating. So that's a kind of a discrete operation. So that's a little bit the question. Basically, the question there when this started was, is it possible to make a discrete architecture? Now I made it less exciting because I already showed, what is that saying? Okay. Nothing's going to explode if I press OK. Okay, good. So yeah, I made it a bit less exciting by already showing you, yes, it's possible to do a discrete architecture. It looks like this, right? Then there's a technical logic. The technical logic, you could say, is the kind of the thinking around how would you actually build and manufacture a discrete architecture, which is anything from robotics to ideas about modularity and prefabrication. And I'll show you a lot of these kind of things. And then, I mean, probably the most important one is then the socio-political impact of this, because anything you do is ultimately, also as an architect, is underpinned by political positions. So the work of the 90s, the digital architecture in the 90s, was underpinned by political agnosticism, which means that it said there are no politics, we are not political, which is a political position, because they were just accepting the fact that architecture was merely kind of something that would not have any impact per se on society. It was something that could be traded and marketed, right? And it's really interesting to compare kind of to basically think through kind of what are the kind of political consequences of when we are working with something like a robot. For example, what happens to labor, what happens to humans, and what would we use robots for in the first place? So that's work. And then underpinning all of this work, and I'll do that a few times, is kind of little side thoughts that are absolutely not consistent with anything. That's just me being an architect, having weird thoughts about buildings. And that also comes in there. And I think that's also important to kind of acknowledge these things and give them a place and kind of think through what they mean, right? And that's just weird obsessions that I have and that you don't need to have. Like, for example, I'm obsessed with kind of megaliths, which is just something, that just happens. Or I like this artist, and I like that artist, but you don't have to like that. That's just me, right? So these are like kind of, I would call it like a picnic in the park, a little side excursion that has nothing to do with the argument. Cool. So research. So I've given you a hypothesis, right? So the hypothesis, that's where research starts. A hypothesis is like, can we make buildings out of discrete parts, and can a discrete architecture exist? And then from that is the question, ultimately, could we make a kind of, could we create a new technical paradigm, how we could produce 2 billion homes very quickly? And then a third question would be, what are the political consequences of doing that, right? So how do you research this? Because this is that's a lot of questions. So as architects, you research this through, through first of all doing the work, and then reflecting on the work, right? So the reflection on the work is, for example, books. So you can order this book on the Evil platform of Amazon, which is a reflection on the kind of, that's in the meantime quite old, it's actually quite outdated, kind of 5-6 years old, which is kind of a reflection first on the body of work that was emerging in a number of places in the world, where a bunch of architects, one of them myself, others a lot of friends, who are working on these kind of questions of like, wait, what is a robotic architecture? What is an automated architecture? How does an architecture made out of parts look like? Then I think as an architect, it's also interesting, and like this is more of like my dirty laundry, I would say, like that's what I don't show to people. Like as an architect, it's always interesting to understand your position, right? And to kind of understand where you are situated in relationship to other people. Like, and I think you can actually also do that as a student. So what I do this regularly is like, I regularly just kind of think like, wait, why am I liking this stuff on Instagram? Why? Who are these people? And you can make a mapping, right? Like this is a mapping of people that I like. I would not admit that sometimes in public, some of them. And I've organized them kind of in like they're very different. They have nothing to do with each other. There are some that are, progressive materialists. Like these are people like Anna Holtrop doing stuff that I would never do personally. There are activists, there are techno-formalists, you could call them, or something I call disciplined autonomists. And it's interesting to understand that everyone's work, or especially like my work, is situated in a kind of a tension between very opposing interests and practices, right? Like you would never think that one person could be interested in Anna Holtrop, if you know Anna Holtrop, and at the same time also be interested in Moss or Assemble or something, right? So it's interesting. I would say like these things are kind of limits, and then as an architect or as a student, as a creative, you kind of maneuver in between those things. And like these are just some images to illustrate how wildly different these kind of extremes could be, right? How are they connected? And then I think that's kind of in a way how I operate is like these are kind of my, I would say, things that drive me, like my extremes, my limits, and I always like exploring limits. I want to know how far you can go with something. And for example, I mean, one of the limits is discrete versus continuous, which is an obvious one. Passive versus activist, material versus abstract, intuitive versus conceptual. And like these are all things that, I mean, I've put those together for myself, but these are things that you can also think about and kind of try to understand better, like, why do I make certain decisions? Why do I like something? What am I looking for? And then in your work, you can tweak the sliders, right? You can be, I'm going to be a little bit more ordered, a little bit more less ordered. I'm going to be more blunt, more abstract, more disciplinary, etc. And that gives you a possibility to understand differences in your work. So, I mean, these are both projects that I did, a few years apart. And I mean, I hope you would agree that it's clear that they're done by the same architect, but they also engage very different topics, right? Like one is much more abstract and minimal than the other one. And yeah, there's like a whole series of attitudes that shift between that. And that's in a way, what you're doing as an architect is in a way doing this trajectory through kind of your extremes and iterating and trying to figure out kind of what would happen if your work would be a little bit more like this or a little bit more like that. And then through that process, you engage with, and that's the beauty of architecture, you engage with all of these hundreds of topics, right? And that's, I mean, to make another blunt statement about architecture, architecture is one of the last really generalist professions. Another one you could say as a doctor, but like a generalist profession in the sense that we know a little bit about everything and we know not a lot, like we never know a lot in detail, right? So like if you would go to dinner, you could basically, like the joke is that if you go home with your first boyfriend or girlfriend, like first meeting the parents, you would be able to talk about anything unless someone goes into depth and is like, wait, do you know this? And then you're like, as an architect, you don't, right? Because our power is that we know a little bit about everything and we can put all of that together. Oh yeah, the other professions are actually like politicians are a bit like that as well. That's actually interesting. Right, and then how do you do research as an architect? It's really simple. I think our medium is buildings. We practice research, we do exercises through buildings, right? So, I mean, not everyone has to do that. You could also maybe do it through writing about buildings. That's also a mode of research. But in my work, it's mainly through buildings. So I basically look at buildings, and I believe strongly that a building, why is the building so important? It's because it's a generalist thing. Like, we can discuss this thing on a technical level, an aesthetic level, a political level, an experiential level, a poetic level, like anything you want, right? It brings together all these concerns. And then other mediums as basically the act of materializing, I think is really important as well. Like, that's really a way to push something, is to try to build something. And these are two different projects, again, 5 years apart, whereas this one is an attempt to build that one. Right? Sketches, anyway. Cool, right. So this was a little bit of a disclaimer in a way to help you understand a little bit like my mode of operation, right, what I do. And now I want to kind of quickly do a quick journey from Spaghettis to automated platform, which will kind of show you, 3 stages in how I started my practice and my different endeavors. So the first stage I call serial or Spaghettis. The second stage is discrete, and then the third one is automated. And they're all related. I mean, they're related by what I showed you before. They're related by basically by positions, right? And by kind of these limits that I'm exploring. So I came out kind of, when I started my practice, I had just done this project at the Architectural Association. That's like in 2012. This is something that is, I would say, really cool, but also not very practical to enter the build world with, right? Like, if you would want to start a practice and you want to go to a client and be like, do you want to live in my spider house? Chances are small, right? And also, how do you build this spider house without massive 3D printers? But I think that project, I mean, as I think most people's like graduation projects, was a kind of an interesting start for me to build a whole world on, right? Because I was so fascinated by the consequences of this crocodile. Like, I was like, this is, there's so much in this thing that is weird and fascinating and interesting, and I want to figure that out. So like, one of the first things I did, like, this is actually almost the same algorithm as you saw in the previous project, but basically my kind of first pragmatic decision was like, let's just work with straight lines, because we can make straight lines. They could be made out of any kind of bulk material, and let's kind of use the same algorithms, but let's just bundle straight lines together, which is a kind of, you could say, a beginning of an attempt to discretize architecture. Then I kind of launched all of these straight lines on a competition. I was 27 actually, on a competition in Hungary for the National Museum of Hungary in Budapest, which then I accidentally kind of won that competition, which was remarkable, with this thing, which is basically just 3 slabs, right? 3 squares that are filled up with thousands and thousands of these straight lines. And I thought, for me, this building was for me probably kind of the most important one, as it was kind of something that allowed me to be at the same time abstract and material, to be really exuberant but also minimal at the same time. Like, these limits that I just mentioned to you are all kind of present in this project. These are the kind of the ceiling plans of that project, which again is just a kind of a repetition of these weird squiggly lines. And I thought this was a kind of a really new aesthetic world that kind of emerged out of that, right? Which resonates in a way with some kind of abstract art that you see this kind of, it's not sculptural form, it's form that is achieved by assembling kind of bits and pieces of material, right? And it's definitely this, like, this is Agnes Martin, abstract painting from the 60s. She just obsessively draws lines from left to right. And I do the same, but with a computer. And I do that like on the train, for example. Like, I actually did that competition in 4 days, just me and a laptop on a train, having an algorithm kind of assemble thousands and thousands of these lines. And then you print it out, which also is beautiful. I mean, in a way, as an architect, that is beautiful that you could do something like that just by yourself, right, on a train, and kind of make a chance. And then when the jury figured out I was 27, they fired me from the competition. I was not famous, so they were like, we'll do it again. This time you can only participate if you have a Pritzker Prize. And then Snøhetta and Sana both won the competition, which means that it will never get built. Right, and then I was really excited by this, and then I tried that again for another competition, which yeah, explores the same ideas. Like what you see here is just thousands and thousands of straight sticks of timber that are assembled together in something that's almost like almost natural, right? Almost natural, but yet assembled, super, super high resolution. And that constructed a huge roof. That's, I think, in 2014, so that's also a while ago. A huge kind of timber roof that, again, only consists of these straight repeating parts. Then that would be the museum. And that's kind of an obsession that I had, and I also did that with the students. I heard yesterday that as an exercise here in the school, you're asked to make a chair sometimes, which is, by the way, a classic exercise that comes from the Bauhaus. And it's a very good exercise. I'm convinced that's amazing because you can explore a lot on a chair. Like I had my students do for a number of years only chairs, like no buildings. They would just work for 1 year on producing a chair. So like that's a chair that is 3D printed, and that is actually the same as this museum. So it's not a lot of timber sticks assembled, but it's a lot of tiny lines of plastic that were extruded by a robot and that are assembled together into this kind of strange plastic mass. Then I did that again together with a colleague, with Manuel Jimenez Garcia, where we again kind of printed these really, really uncomfortable and absolutely unusable chairs consistent out of thousands of lines. So this is not a chair, it's an architectural paradigm, right? And like it's really interesting, like that's why I love this so much, this chair. It's like, if you look at this chair, that chair is actually a manifesto for this building, right? They're actually the same. Like they're very similar attitudes that you can kind of explore in these chairs. Right, cool. So going further with this work, I realized that like after these competitions that this was still a little bit too crazy for the world to build that work. And I was kind of searching for something like exploring this limit of how simple it could go, right? Like how much could we reduce the resolution of this work, and how could we kind of think about the parts that we are building with. And like this is probably the second most important project for me, a part of the Budapest Museum I just showed, which is a villa in Belgium. And I like it a lot because I had absolutely no idea how to build this when I designed it. I was just like, this looks great, right? It consists out of like a lot of small arrow-shaped elements. I didn't know if they were timber or stone or concrete. I didn't know how they would join together, but I really loved this image. I was like, I need to figure out how we can build these things and how we can make this, how we can make this accessible for everyone, right? And I think it's interesting to think like, why is this image compelling, right? So again, you're seeing something that seems familiar, like you recognize it's made for humans. It has two very straight lines, very boring, right? It's just a box, actually, two straight lines. But then you also realize that these straight lines are built with things that we don't know, and that I also didn't know as an architect. They're made by this kind of strange elements. And then it looks kind of a little bit natural and a little bit not natural. And I think it also looks cozy. Like, I wouldn't mind living in this thing, right? That's kind of the model of this thing, which again shows these qualities. And then I tried to build it together with a very unfortunate intern in my office who had to cast all of these arrow-shaped pieces because we were thinking that this building would be a precast, so it will be made of cast elements. The idea is that everything that is red we need to kind of custom make, but they share the same kind of connections with the white pieces. So the white pieces are just repeating. And then the argument to the client was that that it was a very rational and cheap building because it was 95% the same part. So you could just mass produce these parts, click them together, and you would have a kind of a building, right? So we tried that out on a kind of model scale, building this kind of large model. That's the unfortunate intern, Nathan. And then we built it, compared it with the rendering. We had to add, because essentially I was doing the most stupid thing you can probably do as an architect, which is I was building a horizontal brick wall, right? Bricks work this way, they don't work that way. Surprise. So we had to add a layer of carbon fiber, not carbon fiber. Anyway, forgot the word. Glass fiber, which works in tension, and then you could actually keep it together. Anyway, that project then set out this kind of agenda for the practice. Like I wanted to figure out how can we build this in a more efficient way. And then there was just a lot of explorations coming from this, which I just liked to kind of explore, not on a technical or construction level, but really on a kind of purely architectural, aesthetic level, where I was very interested to understand, like, you know, how do you design buildings with this kind of repeating parts? What does it mean? How do you read a building like this, etc. So that then, this led then kind of to that work that you would call discrete, like purely kind of looking at how we can construct those parts and going hardcore deep in the idea of like how can we realize this, right? So essentially what we started to do also with the students is kind of seeing how we could fabricate those parts really cheaply, and then how we could train robots to assemble those parts into structures. And again, you see where it all started, right? It all started with a chair made out of lots of elements. And it's actually that kind of idea is not only, that idea actually exists out there, like it's not my invention. There exists a kind of a paradigm around the kind of organization, you could say, of digital parts. Like it's kind of like 3D printing in a way, you could say, but it's 3D printing with repeating elements. So like NASA is using this to build satellites. So they have these little robots climbing structures that they are building by depositing kind of repeating elements. And that's super exciting, right? Because in a way, like when I was looking at that work, I was like, this is brilliant. I mean, we all know that like modular architecture is really efficient, and we all know it sucks and it's super boring. It's the death of architecture. But in this world, it could become exciting, right? We could really kind of make an entirely new idea for how we could relate to parts and robotics. So this is kind of these experiments where we're building chairs always from the same element, right? This is modular architecture in a way. Again, very dysfunctional, weird chairs. This one was made of little penguins that I kind of assembled together into various structures, you know, kind of working through these ideas of these kind of crawling robots, depositing really cheap elements. And then really the idea that was really beautiful in this project, which was really this idea, like if you could build in this way, these blocks, you know, they could also be removed again. So there's kind of a whole idea that as a platform for affordable housing, we could reset the way that you buy a house like this. Like maybe you're just leasing these parts, maybe you don't need to buy them. And if the work is done by robots, you know, technically it doesn't cost anything. You just need to kind of subsidize these robots. There's no human labor involved. And we could have robots kind of create environments almost for free for us to kind of dwell and live and inhabit in. So suddenly there was also kind of a political project or kind of a social project attached to this. I'll just show, like, I'll just exit the presentation quickly to show a little video of the most extreme version of this work, which is called the Pizza Bot. So the Pizza Bot was based on a pizza box, right? A square box. The orange one is a robot. The white one is just a timber block. And the idea is that the robot, you know, with the same geometry as the brick, can assemble various structures, and then these robots can also collaborate together and build things together. And that's then in the corridors in the Bartlett, where the students actually built these robots. So they're kind of walking through the corridors and kind of showing that, you know, that we could actually do this, you know. And then we simulated this on a larger scale using an industrial robot, because we don't have the knowledge to build these robots larger, so we kind of just simulate these movements. Then also started using reinforcement learning, which is a form of AI, to train these robots. You should look at the third one. He's like really cute. He's struggling a lot to kind of train these robots to understand their own movements, right? Great. And then this was then kind of the vision of, you know, what an automated architecture could be. So you just drop a few containers with a lot of timber elements on site. You have 40 of these robots that are all working collaboratively and kind of trying not to bump into each other. And they literally almost grow the building from these repeating parts. And like for me, that was really interesting, right? Because in a way, we've taken a paradigm of, you know, that is known kind of to be, you know, almost modernist, right? Like repeating modular elements, boring, 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 but then it becomes something super exciting and completely automated, right? Back to the PowerPoint. Right, and then the students also built this like full-scale prototypes. And then we kind of, with the students, speculate a lot on housing, right? Like, for us, it was really the agenda was to think how we could build housing with those repeating elements. Like this is all modular architecture, right? And then it's interesting to kind of reflect back, like I mentioned in the beginning of my talk, a few of these hero architects, right? These architects who all went bankrupt and who were thinking that they were going to change the entire world of construction, right? Like the very material that you built with. And there's another attempt that we don't really understand a lot about, but I'm kind of writing about this, is that architects sometimes, our ultimate dream is actually that we, there's a fascination with kind of trying to make building as kind of simple and blunt as possible. And of course, the 0 degree of architecture, the most simple that you could make it would be if it's an architecture that only has one part. And that's not just a kind of an idea about, to try a theoretical idea to try to make architecture digital, or like, it's not, none of that. It's actually a psychological kind of deep desire in architects that our profession maybe could be simple, that maybe we don't have to struggle, that maybe we can also go to the beach, maybe we can have a lot of beers with our friends, and maybe we don't need to be poor, and we could just kind of build in a really simple way, right? And so that's Frank Lloyd Wright. He did that, like, I forgot the date now, like I think somewhere just before or just after the First World War, where he developed a textile block, which is a really beautiful concrete building element. And his idea was, like, he was so tired of designing, he was like, I'm just going to design one building element now, and from now on, all my houses are going to be done with this building element. So I'm done with architecture. Just one detail, and I just repeat it, right? And every time I make another house with the same elements. And then this one here is by Walter Gropius and Konrad Waxman, which basically Walter Gropius, when he escaped Nazi Germany and went to the US, he decided that he also had enough of being creative as an architect, and he started a company. It was called the General Panel Company, which had developed a timber building block. That's a whole house there, flat packed. And his idea was that he would build 10,000 homes a year, which would all be different, but all be assembled with this timber panels. And he even built a factory for this, like that's his factory. Anyway, so that's kind of an interesting, I kind of feel affiliated with those ideas, right? So in the story of me trying to build these things, I won a competition in 2017 to build a pavilion in Tallinn for the Architecture Biennale. And that was kind of a moment where I could finally, demonstrate on a large scale that work is buildable, that you can do it on budget with little effort. The idea was to build a kind of a domino. So it was not a pavilion, but it was kind of an abstract fragment of a larger housing block. That's an image of that larger housing block. And then the pavilion would be kind of a small segment of that structure. And it would be really simple, like we would just buy timber. You would CNC cut the timber, build them into elements, and then the elements would be assembled into the pavilion. And the elements are all connected dry. They're just stitched together under tension with a steel rod. And then, which means that you could also disassemble the pavilion, reassemble it into something else, or bring it back to its initial building blocks. All of the technical details are hidden. Like, I was really looking for this kind of abstraction, that you would not show any of the engineering that is in the project, but just kind of reveal only the building block as something that you really don't understand how this thing is standing up at all, and kind of hiding the complexity. We set up a little factory. I hired these 2 Germans here, which I randomly met in a bar in Tallinn the day before we were building, and then they were sleeping here in my workshop in the back here. And they were building blocks for me, so no robots in this case, just 2 German timber workers. So we built, in 4 days, we actually built all the parts, all these massive Lego blocks for the project, shipped them on a truck, and then went on site and clicked these elements together. You see the joints here, so that's where you put like a steel rod through it, which tensions these blocks together into a structure. And then you see the kind of the human scale, right, of like one person versus one block. And then the assembly of that thing there. And then it was really exciting in a way as a kind of a playground, right? Like there's so many weird things going on, even though it's a completely kind of modular architecture. And I think there's also something, it looked really different from different angles. And I think it's quite exciting to make an argument that it's not because architecture has to be economic and efficient that it has to be sad, right? Like that's a really kind of exuberant corner with a lot of kind of, a really exuberant language in a way for something that is built out of repeating elements, out of cheap materials, and with a minimum amount of labor. So I like that. And then that was the moment where I was like, aha, this project that I failed to build with my unfortunate intern, actually, now we know how to build it, right? We actually did it on budget in a very short period of time as a large building. So then, of course, the speculation and after that is like, okay, how does housing look like when we begin to assemble all of these elements, right? And then I had another chance to this is kind of a repeated exercise at the Royal Academy in London, where again we built a series of these parts, which are very lightweight. This guy is not very strong. That's Ahmed. It's just a lightweight block. Then kind of transporting these blocks around the building. That's my engineer who's still very worried at this moment about her life and her insurance. And then we're building the parts kind of in the galleries of the Royal Academy. And then the building site is really interesting. It's actually, there's no craft involved. It's just organizing these elements into larger chunks and bits and pieces and kind of clicking them together into these larger structures. And that was also for me a great moment again, that you could show, that you could finally experience this as a space, that you could kind of sit in there and kind of understand how this operates, right? You have this interesting contrast with the ceiling as well. And again, to make the argument, the provocative argument, that this is an affordable architecture. This is not expensive. This is for everyone. This is not a kind of an exuberant architecture in a museum. Then we had some meetings there with Peter Cook and Mario Carpo here. Actually, you can't see the installation. It's covered with people debating automation. And then following that, there was really kind of an attempt to, push this then to the real world, right? So we built a really small house in Belgium last year or 2 years ago, which is basically just a square with 3 feet, always consisting of this building blocks. The red lines you see are these tension lines, the way that this is stitched together. Then some images of the building site, which in its own right, again, I think looks beautiful as a building site. Oh, he's back. I think looks beautiful as a building site. It's almost like these sculptures, right? They're kind of flying around and that are then being assembled. Very, very bizarre building site. This is, I love the contrast again between how you would build this, right? The kind of old world, and then this very abstract, really bizarre way of these large elements coming together. And then that's a client, his living space. Now, I'm not sure I would want to live there, to be really honest with you. He's an actor, so he's a flamboyant and extreme personality. So for him, it's this is amazing. I can show my friends. But it's a little bit much for such a small space. But it's, again, interesting to consider, in a legacy, right? That this was built under budget per square meter compared to normal building system in Belgium. And again, the idea that you could kind of mass produce this, right? That you could produce hundreds of different buildings, always with the same repeating parts. And I'm not even talking about anything like sustainability in this case. It's all timber as well, so it's all also storing carbon, right? And then maybe from an architectural perspective, I also think there's some really weird and interesting things going on, that this is essentially an extremely boring project, right? It's just a flat roof with 3 columns, right? But then it gets its interest through the fact that nothing that you see in this image is actually recognizable. Nothing is something we are familiar with. It looks really something like we know and something that we don't know at the same time, which I think is interesting. And that's, this project was done before the 2 that I just showed you. But again, then, if you look at this image now, you would be tempted to think that we could actually build this and that it's actually not crazy, right? It's just a modular repetition of the same part, right? And again, I think this is probably the best example of what a discrete architecture looks like. So it's an architecture where you have no more types that so there are no floor plates or columns or beams as such. This is not a floor plate, this is just the same part that is repeating. It's vaguely familiar and vaguely not familiar. And basically you're surrounded kind of by the same material operation that defines the floor, the ceiling, etc. So it's a bit almost like a cave, actually. And that's actually interesting, like to consider that although this architecture is discrete, its experience, we call it like phenomenology with a difficult word, its phenomenological experience is continuity. Like it actually results in a continuous space, which is a nice contradiction. Right? These are some really black drawings of that space, which is, I mean, pretty open and free. I will not talk about this. I'll talk about that. Oh no, I will talk about this actually. Like this is funny. So like this is my architectural history class with Gilles Retsin. This is everything that happened in architecture in the last 100 years. So architecture got reinvented here, 1915, the domino, Le Corbusier. This changed the world for 50, 60 years with a social project to build housing for everyone. It redefined aesthetics. It redefined the way that we lived. And it literally, I mean, the most extreme thing about it, and this is nuts, right? Architecture before this was defined by the wall, and now it's defined by the floor. Like, brilliant. Then this is postmodernism. Charles Jenks, Robert Venturi. Basically, they didn't change the economic system that constructed this, and they were just trying to get rid of it, right? But you can't get rid of it because postmodernism is just post. It doesn't have a new way to make things. It just doesn't want to be modernist, right? So you would decorate the domino with, you know, some other elements that seem to contradict it. Then this was one of the funniest moments in architecture. Peter Eisenman, Wolf Pricks, Vienna, which is deconstructivism. That was basically taking two dominoes and making them unbuildable and complicated and expensive by, you know, intersecting them together. Two grids. At that moment, architecture loses all its functionality and becomes kind of maybe truly, yeah, well, it becomes something else. The only question is like, is it better or not, right? Then this is the last 10 years, like parametricism, Patrick Schumacher, Zaha Hadid, where basically you add a layer of curved plasterboard around the domino so that it doesn't look like a domino anymore, but like a continuous space. And then some other people tried to make dominoes look like objects, especially in the US past few years. They really tried to make it look like an object, but the moment you open your object, you'll see that there's still a domino. So essentially, it's impossible to get rid of the domino. The domino still defines everything today in architecture. It's so, as I said before, it's so stupid, yet so smart and so resilient, right? You can't do this better. So this is my provocation in that actually you can, right? You can change it, right? So this obviously, as a provocation, looks the same, but it is different, right? So it's not trying to look like anything else. We're looking at 3 floor plates, but all the substance of the domino is gone, right? There's no more floor plate, there's no column, there's no hierarchy between building elements. You enter like a new paradigm where you just have a repeating pixel-like building block that can be structured into space for humans to live in. So it looks the same, but it is fundamentally different. There is nothing in this model that we recognize anymore from this model, and the entire way that you would make this has also changed. This model, you know, is really bad for the planet. It makes sure that, you know, the building industry is the most polluting industry in the world, right? That's because of this model. This model is different. That model is conceived out of timber assembled by robots, circular, removable, adaptable. This model supposes that you're all Le Corbusier, if you live there, like white male in their 60s, round glass, oh shit, yeah, round glasses. And then this model could be adaptable, it could be different for everyone. Right? And then the interesting thing about that as well is that it's actually really, really primitive, right? So if we push architecture to its most extreme, and I would say like its newest version, it actually, again, ironically becomes the oldest thing, right? So, you know, we used to build like this, but this is actually kind of the same, right? This is just taught through kind of algorithms and robots. Both come from the forest, and both almost on an aesthetic level also share the same. So maybe really new, what I just pitched to you as really new, and the newest thing is maybe really old, right? Maybe it's just a kind of really primitive way of building space. And then there are questions around, I think I'll go a bit faster actually, yeah? I'll start speeding up now, okay. There are questions then how you make this larger, right? How do you scale this up? Like, could you do it just with a few really large parts instead of a lot of small parts? And I do want to explain this project in a bit more detail, sorry. So this was another competition actually, which is funny, in Germany. So in Nuremberg, bye-bye. In Nuremberg, he has to pick up his kid. It's not because the lecture is boring. Yeah. Yeah. So this was a competition in Nuremberg for a new concert hall. There's an existing concert hall. They want to refurbish this one and build a new one. If you do competitions in Germany, it's the worst country in the world to do competitions because they are like really, they just want a box, right? There's no way out. They just want a box. So my strategy was in the first round was to exactly give them what they dreamed about. I was going to give them a box. They didn't want renderings, so you couldn't detail the box. They didn't know how it looked like. So the plan was to give them a box, the perfect box, get selected, and then when they opened the box and understood who we were, they would see that nothing in this box is what it seemed it was. It would be built without, you know, exactly as how I described before. It was a trap for the Germans, and they would have to deal with our project. And how are we going to build it? We're going to build it basically with CLT sheets that we would get straight from the forest, a bunch of robots that cuts elements from the CLT sheets. You make little triangles, pack them in a truck, and assemble them on the site. Algorithmically, it's combinatorial. So just what I showed you before in the beginning of my talk with all these little lines that assembles. Here it's just little V-shapes that assemble, and they construct horizontally and vertically, they construct architectural features, which then you can translate into the CLT sheets. And then that becomes a kind of, yeah, a kind of a really, really, you could say deeply rational architecture, but also very unexpected. So you see like the digital model on the left, and then on the right, how it's rationalized into, I mean, really 0-degree architecture, right? This is so repetitive. It's just the same sheet of CLT put into a triangle, covered, and then you get a kind of a timber monolith out of it. And then these are all the elements you need to build a concert hall. If you want to try this at home, you need these elements. These are people. They're huge. That's all the material you need to build a concert hall, laid out flat. Still okay, right? I mean, just with this you can build a concert hall. And then that's a concert hall. And you see it's a box, right? That was the German trap. So it's a box, but at the same time, it's also not a box. You cannot understand this as a box, right? It's you can only understand this as a repetition of the same timber element throughout, right? There's not even a floor. Like you literally walk from this element, you step, and then you step onto another element. There's no floor. There are no columns in this building, and there are no beams. And I know you guys are saying like, no, come on, there's a column, there's a beam. No, this is exactly the same element. Because what happened is actually that, I mean, I was willing to compromise. So I told the engineers, like, of course you would expect that the timber pieces on the top would have a smaller dimension than the timber pieces at the bottom, right? That's what you would think. No, because the fire regulations override the structural regulations. So the timber is the same everywhere, not because of structure, but just because of fire. So there always is, like this piece here is the same piece as this piece, is the same piece as this piece. Oh, they're all the same, just repeated throughout. And it's a super weird thing, right? It's a building that, again, it's almost like it's a monolithic building that is assembled out of timber. Like normally monoliths have no parts, this has parts. Like it's a strange thing. That's the kind of, the lobby, there are two lobbies above each other. And again, you see the same operation in a very reduced and abstract way. A large beam here, a large element there. And then of course the staircase is an exception. I love exceptions. I think exceptions allow you to see, you know, the rest of it. Like if you don't have an exception, you don't understand what the system is. You need it to accentuate the system. And I was consistent that I gave the staircase to a friend to design. I didn't design it myself. I just put it in there. Like I commissioned him to design the staircase and then added it to the system. Like you always need to know when to stop as an architect. Don't try, like my rule when I stop with this is like, basically anything that caters to the human body, like that you need to walk or sit on, please don't do it with discrete timber pieces. Like they're sharp, they will hurt you. Don't make toilets with discrete timber pieces. Don't make staircases. Don't make benches. Like do nicely continuous, you know, soft benches, curvy staircases, sure, right? Like it's really important to know when to stop. And then the most radical thing about this building is probably that 99% of the building is robotically fabricated. So you only need to go back to the existing building industry to buy a little bit of insulation and the window. All the rest comes out of, you know, It goes from the forest to robot to the building. So that's an entirely new way of building, right? It has nothing to do with the existing construction industry. And that kind of leads us back actually to the model that I showed from OMA before, that basically architecture today, we used to be a spatial profession, but today we are a superficial profession where we can only design the kind of suspended ceiling or the decoration. We are no longer in charge of a lot of the building. We have given away everything to other professions. But the moment that we built in this way, we again get the power to make architecture a spatial profession where we can define everything, except the fire alert, which will always be there. So we can beat this model, right? We can again become a monolithic profession. All these people will run out of work. All these horrible building product fairs, you don't need to go to them. Brilliant, yeah? So it could again kind of become a profession where as an architect you kind of have more power. Obviously the Germans didn't let us win this competition, right? Like they were like, you guys are crazy. I think if we would do it today, we would win it. Like back then it was still too early for timber. This is like 4 or 5 years ago. So I did the same competition again. I like to always be kind of, I'm a strong believer in that intelligence is laziness. Like, that's actually a challenge for you as students. Like, who's a smarter student? A student that works the whole year, every day, and gets a 9.5 out of 10? Or a student who works the last 2 weeks and gets a 7 out of 10? Who did a better project? I would argue the 7 out of 10, right? Because they found the right ratio between labor, effort, and output. So that's real intelligence, is the 7 out of 10. So part of my bad advice for students, So I wanted to kind of recycle this project, so I just turned the concert hall 45 degrees for a project. Then you have a roof, right? You have a pitched roof. So I was interested in exploring, the next boring thing after doing a box. The next most boring thing you can do as an architect is doing a pitched roof, right? I mean, if you're really not creative, just do it. So perfect, I make a pitched roof. And exactly the same idea, so fully automated, robotically cut, assembled. And then I designed this kind of, this had a bit more exceptions. This is actually not that modular. And then created this kind of massive barn, right? Which if you turn your head now like this, you'll recognize the concert hall, right? And again, I think this is a really interesting building because it plays the same game that I mentioned before. It's a box, but it's not a box. This looks like a pitched roof. It's not a pitched roof, right? It has nothing in common with any pitched roofs that we know today. And then it's this kind of old typology that we think we all know, like the barn, but then it's also very different. You had like ceramic, kind of a ceramic edge there. Yeah. So, the most boring and predictable typology. And then I did that, I won't explain this, that's just the same. This is another one, which we actually won in Belgium. And then you can, I like this kind of this primitiveness, right? So that's something I recently did, which is, was playing around with one of those image generators, which if I were an architecture student today, I would be playing with this non-stop. That's like DALL-E and Midjourney. This is done with the beta version of Midjourney. You can just try this out. So this is completely AI generated. It's just a text prompt, like you just write text. I wrote something like a photo of an architecture model made out of thousands of timber pieces, which is a description of my work, right? And then the AI tried to kind of assemble all these timber pieces, and it throws back this kind of really cute and endearing, strange huts, right? Which look like they have been made in reality, but they have not been made in reality. And I think it shows kind of for me what I mentioned about kind of the relationship between something primitive and old and something new. And I think it's super fascinating to see that this is made not by a human. It's been trained by me. It's like a collaboration between me and an AI, which I think is really, really, really fascinating and strange to think about. And actually, it's funny, like after I published these images on Instagram, I got a message from a curator of a really large museum, and she was like, where can I go see these models? Because they don't exist, right? These are not real models. And I was like, okay. These are some more of this kind of the game between like a familiar typology, the barn, and then something algorithmic, right? All of these barns. Cool. I'm going to try to almost wrap this up, guys. So this is something I want to build for myself. I think that would be a nice house in the forest. If ever I can, I will try to do this. Again, the same modular elements, etc. Cool. So this brings us to the third chapter, and I think this is the most exciting chapter. So basically everything I told you before, if you remember, I started the talk by saying that we should think about 2 billion homes, right? Everything I showed you until now is not getting us much closer to 2 billion homes. I showed you museums, showed you not expensive, showed you nice villas for like a few people, but we're not solving the question of the 2 billion homes, right? We're not automating architecture. And like in a way, the work that I showed you is the same work in the beginning when I showed you a slide of the L. crocuses. Like there has never been as much good architecture. It's the same, it's boutique architecture. So I believe that the real power of the systems that I just showed you actually require a different format than an architectural practice, because I just have to fight with German juries and annoying clients, and I'm going very slow, right? So the question is, why don't we ignore the whole reality of how we work as architects today and just make a tech company to bypass competitions, Germans, and clients, right? So that's in this chapter. So basically, it started, you could also say with the architectural question, where I was thinking just about, building the most stupid version of my own work, which is just based on a box, right? A simple box, like not a triangle, just a box. And I built an installation with these boxes in Seoul in South Korea for the Biennale, in the Biennale of Seoul, which are large architectural models. Like these are not prototypes, these are models on a scale 1 to 3. So normally you build a model on a scale 1 to 100, right? But this is a model on a scale 1 to 3, which is really exciting because then it means you could scale this model. If you make it 3 times bigger, you have the actual building. And they're just these timber boxes, always the same ones, with a steel cable that goes through. That's a scale, right? You can see these kind of 2 models together. One is really domino-like. Like this is really like the kind of Maison domino. Very, very simple. Almost the diagram I showed you before. And this one is a bit more exuberant. And again, the steel cables. You just need to cut the cable and then the model falls apart. The domino one and this. I think that's the most boring thing I think I've ever done in the last 10 years, and I think it's really exciting. Like it looks so simple, yet it really works, and it's very, very different than anything else we know, right? Like that's an argument I made before. And it's a little bit this game, right? Kind of, again, kind of affinity with minimal art and the kind of recombination. And then it produces really exciting spaces. I mean, these are kind of like Miesian spaces, little voids, etc. And then in the end of the exhibition, the Koreans did take it apart and they reassembled it into a permanent bookstore for the museum. Like that's a table or a villa. This could be a housing block, but it's a bookshelf, etc. And that's a drawing actually by Frank Lloyd Wright from 1908, which shows this. I mean, I think that's beautiful, right? This is kind of extreme possibility. Could architecture be this simple, right? Right, which is this model. And then some other versions of that, right? And I think like this brings us to, I think this kind of genericness brings us to a different question as architects. Like I've always been fascinated by this, right? I think architecture appears in large quantities. And the question is, could we begin as architects to work not on the 1% project that goes to L. crocus, but could we work on the 99%, terrible, dull, and polluting environments around us, right? Could you actually tackle this system? Like that would be so good for everyone, right? If you could do that, like this question, right? Not the 1%. And I'm not going to explain this too much, but like we're in a bad position to do this, as I mentioned before. We actually really don't know how to do that as a construction industry at large. This is a graph showing who's most digitized. So we are somewhere as architects, we are there. Construction is the least digitized industry after agriculture and hunting, right? And like even to put that into context, that's actually agriculture in the Western world is actually really digitized. So the only one that is less digitized is hunting. And hunting should not be automated. Don't automate hunting. We don't want to hunt animals with like robots and drones and AIs. That's cruel. No. Like we want to keep hunting a craft, but we don't want to keep construction and architecture a craft. It should be automated. And like this one here, that's also a really cool graph that shows like the productivity. So that basically means like for the amount of money that you put into it, how much do you get back? So basically since 1947, the construction industry has not managed to become more efficient. So anything we have done collectively as a profession since 1947 has not changed anything. Even if we draw in CAD and if we draw with BIM and if we work with new materials, we are not building more efficient than in 1947. So you could say like anything we've done has not made a difference. Building is still horrible, expensive, and impossible. That's I should have changed this to 1947 actually. This is Le Corbusier, right? He started building this in 1947. So you could say that everything we did since this building, not valid. We haven't changed anything. This guy again, right? And one of the other reasons is psychological. Like, as an architect, every building you make is a prototype. Like, every day is a new day. We begin every day again as an architect. That's what you learn in architecture school. Like, every studio you do, you need to do something new. I mean, which makes sense if you're studying. But like, this kind of idea keeps coming. Like, everything I showed you before, every building I showed you, except, I mean, I'm trying to do that with like copy-pasting from one competition to another one, but still we invent a lot, right? So like, this is actually architecture. So I don't know if you've seen this movie. It's a really bad movie, like you don't have to watch it. But basically, Adam Sandler, on the right there, he falls in love with Drew Barrymore, and Drew Barrymore has no memory. So every day she wakes up and she forgets she's dating Adam Sandler. So Adam Sandler needs to convince her to fall back in love with him every single day. So every day is a new day. So that's architecture, right? You do a project and then the project is done. You've developed so much knowledge and then you stop and you begin again, right? Very, very frustrating. It was also very frustrating for Adam Sandler. So at some point, Adam Sandler just solved it by recording a movie of him telling Drew Barrymore that they've been dating, for a year, and she should just date him, which is what we should do as architects, right? So if a building is good, if it's so good, why don't we repeat it 1,000 times, right? If it's good. Like, London is a city that consists of one building that has been repeated 1,000 times, 10,000 times, and it's a great city. It's a beautiful city. It works, right? Mies van der Rohe, all his work was meant to be repeated. He was a lazy man. He just wanted to copy-paste his building 1,000 times, right? It was meant like, he knew it was so good, it had so much quality, he wanted everyone to live in his building, right? And these guys, the ones that I mentioned before, or friends from the Bauhaus, when they went to the US to build a factory for 10,000 homes, they wanted to do the same, right? They didn't want to kind of sit down and struggle to design one building. They solved building forever, and then they just want to repeat the same designs. And that's kind of the context. This question now is coming back to architecture, like I showed you this before. Basically, now there are a lot of companies that are jumping, funny enough, on the agenda of the modernists. They're trying to build dominoes again, this time in timber with the ecological agenda. And they're trying to kind of, do tech companies that sell homes. Like, this is the house of the future. That's a house designed by a tech company. And they're trying to sell this 10,000, 20,000, 30,000 times. Much smarter than an architect, right? So I decided, this is great. I mean, this building looks like shit. But I was like, okay, I am going to try to do the same as these tech companies. And the tech companies, they fail. Like, all of them fail. Because, I told you in the beginning, architecture is really, really, you can't outsmart architecture and construction. It's something that is a fine balance between stupidity and intelligence. And these guys like Katerra, for example, that was a company in the US, they were given $2 billion and they didn't manage to do it, right? And there are so many of them. Like, actually, just today there was another British company that tried to do this that went bankrupt. And there are also other architects who are trying to do this. Like, there's Woho Systems, which is Ensemble Studio, Anton Garcia Brill. He started, he's a few years ahead of me with it, but he started his own building platform. Really, really nice work. Intelligent City, which is based in Canada. Sorry for the pixelated image. which is also doing this, also started by an architect. Great stuff, like they also a few years ahead of us, doing really great work. So I started this during COVID, actually. I started this company called Our, which stands for Automated Architecture. The real reason was that before COVID, I was always flying around to do talks like today. And then I was really bored sitting at home with COVID. I was like, what do I do with myself? So we started this company. And the idea is based on this really simple, blunt thing, the building block, which you understand by now, one building block. We robotically assemble the building block from timber. Then we can grab the blocks, assemble them into larger chunks. And we basically know all the data before. Like we have a kind of data model that underlies this. This allows us to build tiny factories. All these companies I showed you before, they essentially go bankrupt because it's really, really expensive to build a modular housing factory. You need hundreds of millions. And the moment that you have built your factory, you have spent hundreds of millions, and you still haven't sold a single house. So if you don't sell enough houses quick enough, you go bust. These factories cost nothing to build. You can set them up here, you can set them up anywhere, just 3 robots, an algorithm, and you can build houses. And then if you sell 2 houses, you've paid back your factory. So we're trying to, we did this together. We got a strategic partnership with ABB Robotics, building kind of boxes. We can build these boxes now in 45 seconds. We can build 1 box, which is incredible, super fast. Then we put the first product on the market. So we actually started selling as a way to train the team and to show that we were serious and that we could do this. We started selling this customizable, like tiny homes or like backyard homes, which are robotically fabricated. And yes, they don't look that exciting as the work I showed you before, but also they don't have to be that exciting. This is 99% repetition, right? It's they still produce, I think, really nice spaces for people to live in. They're super affordable, like they're really kind of the best kind of quality price on the market. And so we've been building, like, we're actually building another one right now. We've been building a whole pipeline in the UK selling these houses. We also build our own windows, everything, right? So a client just needs to come to us. They say, can we buy one of those? And they say yes, and then we build it. No architects involved. I mean, everyone in the company, 50% of people are architects. But anyway, so like this is very different, right? There's no contractor involved, anything. There's some more of these houses. There we go again. And then these are all the ones we are currently working on. And you see that they're all different, but all based on the same system. And I think none of them are particularly exciting, but they're all good enough. They're all 7 out of 10, not 9 out of 10. Right? Then Boris Johnson got really excited by this as well. He was like, "This is the future of housing in the UK." No, he was actually asking if he could also build cottages with it, not just and then we also think that this raises a new and really interesting question around architectural authorship and what it means. Like, if we have these blocks, could we involve like more stakeholders from the very beginning? So I actually did projects with, this is a bunch of people in Bristol who are all on a waiting list for a house, like an affordable house. So we had them kind of speculate with us together, designing a kind of pavilion/prototype for affordable housing and having them kind of dream about, that affordable housing doesn't need to look like this thing here in the background, but it could be a really beautiful and exciting project, right? Then we did some more of this. This is with Hackney Council in London. Hackney has 400 sites in the middle of London that they don't know what to do with. So we took like one of those sites and tried to convince them that we could build housing on this. So this is, again, a kind of a domino prototype, just with the same building block all over, right? And again, kind of being hopeful and optimistic that affordable housing can be exciting, it can be beautiful, can be for everyone, and good for the planet, right? That we could build this super cool house. Like it's kind of, the photography was not that good for this project, but it was super nice to kind of walk around this thing. And then there's also really different models, like this we did for a developer in Bristol, where he wanted to build like 100 homes on one site. So we proposed to first build a factory called The Factory out of our building elements or blocks. You would make the houses, you would put the robots in this factory, they would build the neighborhood around it, and then once the factory is done, you would refurbish the factory into houses itself, right? So then this would become, the factory would be become a housing block itself. And then we kind of built a section of the factory in London just a few months ago. We were experimenting with these really large beams to construct a kind of a house for a festival in the middle of London. And again, like this is, I think again, this is a kind of a space that I like. I mean, it's not finished, of course. There's some halls left open. But yeah, this, again, like we built this for like 50,000 euros, like this whole thing, which is pretty incredible. Like the idea that you could have a space like that widely available, right? So that's kind of a whole pipeline of projects that we're working on with and ultimately our mission is really to build this, right? Multi-story, discreetly assembled housing for everyone. Yeah, so that's I think I had I have some more thoughts, but I'll save that. Maybe quickly for you to think. So for me, it's interesting to compare these two modes of practice, right? I've spoken about how I work as an architect. I still do my architecture practice as well, right? I would not be able to, I can't choose. Always been my problem. So I can't, yeah, I want to do both, right? I think I want to do the 1% and the 99%. And it's interesting to compare the two, to understand, you know, what's the difference between this world and that world, right? So in a way you could say it goes from large quantities of parts, thousands of parts, to large quantities of buildings. What's more interesting, or do we need to even compare, right? Or also questions like, how do you compare this, right? Like if you could choose to build something for, like these are two houses where I'm in doubt if I would build them, if I would have enough money to build a house for myself. Do I build left or do I build right? Maybe you guys can help me decide. Yeah, or the difference between this, right? Is it the same ideology, but very, very different? Right, I'll skip this. Yeah, thank you so much. I need to speak 15 minutes more? Okay. You don't have to ask. You can also ask questions later if you want to. Yeah. I'm available for beers and questions and debates later as well. Yeah. Yeah. So you showed some kind of approach, which is, I would say, to be explicit, right? So you try to automate the whole workflow. At the same time, there is this notion now with the robotics to give the robots actually some kind of, let's say, own thinking about how they approach the building process. We had a recently lecture from Daniela Peterberger, yeah, where they are, implementing sensors and stuff like that in Japanese exhibition in So what is your thought on this? I mean, I think it's super interesting from an academic point of view and a scientific point of view to understand the agency of algorithms and machines. Right? It's I was saying, like, I think it's super interesting from a research perspective to understand the agency of machines and to do those experiments, like to try to understand, like to try to learn more about us as humans by seeing machines create and build things. Like that's a bit this attitude of trying to build more and more autonomy into machines. What I'm doing here is very different because I actually try to tackle like a problem, right? And it is very explicit. It's a very explicit problem. And I don't think that the agenda of autonomy in any way is like able to answer that anytime soon. Like that's more, a super interesting, beautiful agenda to think about, but we're not going to solve, I think, the fundamental questions about our profession, about the climate, about how we should live together, we're not going to solve that with that. So, yeah, interesting, but maybe not sure about the impact, right? And like for me, it's important to have that impact. Yeah, that's actually a great question. Like, there's actually just now that we're here. So there's like I believe that automation ultimately is about removing labor from a process, right? Like it's a very old kind of a super old human dream that we could make things without having to work, right? We're so lazy, right? Like all our efforts to develop computers, robots, everything is driven by the idea. I mean, it's a more evil idea to remove labor because it costs money, but it also has this beautiful side that it removes labor to maybe create time, right? And I think as an architect, that notion of like time and labor is really important, especially today, right? Where there's a lot of discussions around architectural practice where you don't get paid enough for the time that you invest. It's no longer tolerated, at least in London, that you ask people to work, you know, late hours and like the all-nighters. Like everyone's becoming more and more conscious about these things, right? So, like with the sketches, I've never really understood the role of the sketches that I do. I just know I sketch all the time, like to put ideas down, and it's very quick. You can very quickly kind of put an idea on paper. But then there's also something beautiful, I think, as a kind of, I call it like alternate automation, where I recently did a project with the idea like, could you shortcut an entire process of making something? And the context of this was essentially, well, these are just sketches. The context was actually that I needed a dining table for my apartment. And I was like, okay, I'm going to design like, I'm going to start from scratch, right? Like every day again, like the movie I just showed. And I was like, I'm going to create a modular table system, and then I was like, I don't have time. I'm going to spend like 2 weeks designing a table and then making it. I don't have time. And then I thought like, well, it would be great if I would just make a sketch in 5 seconds, make a picture of the sketch, vectorize, like turn the pixels into vectors and just CNC cut it. And I would have a table without any design efforts. I wouldn't even have to think about it. And I was like, this is brilliant. That's the future, right? This is pure, that's real automation. So I did that. Like I made this sketch and I CNC cut the sketch. Of course, I mean, I had to put in like a few details. That took like 2 minutes. And then I built a table. That's my dining table now, right? And I was like, that's interesting, right? I don't know, like, and then I looked back at like these sketches and I was like, wait, you know, how beautiful would it be that you would just do this sketch and have a similar straight line to making it, right? And like another thing I'm doing with the sketches actually, which actually also responds maybe to the previous question, which is interesting, is that, so I've sketched, I feel like, let's see if I have one here. Yeah, I feel like 1 Moleskine per month, right? And I always use the same Moleskine and the same pen for 10 years, a little bit autistic. So this means I have an enormous data set of sketches. I have thousands of these sketches, which means that technically I could machine learn myself, right? I have enough data. Like I can feed the computer myself. No one else, you guys can't do this. I have the data set, right? Which means that then I don't even need to do the sketch myself anymore. And then you would actually have an autonomous machine that thinks that it knows my sketches, being able to produce my designs, right? In the same way as I showed you this kind of mid-journey, this image-generated huts before. That would be really cool, right? Then I could just kind of create a sketch like that and then immediately just, you know, send it to a machine and get it manufactured. It's a bad answer to your question, but I mean, I love sketching as well, like just for the sake of it. I think it's a really direct way of getting, it's a way of thinking, right, to do it. So I think there's there's some qualities in some of the sketches that you just only can do by sketching by hand that I think you can't, somehow you can't do if you do it in the computer on Rhino. Yeah. Mm. Well, the cool thing is that like in the table, it has all the mistakes of my sketch as well. Like it has, you know, kind of the squiggly lines, imprecision. Like it's very interesting. Like, yeah. And like the question of authorship is also interesting, right? Like, I mean, it's to be debated, but like when I showed like the AI generated huts, I think those are, you know, they're really well designed, not by a human, right? But they're well put together. So, yeah, it's a long debate what it means, right? To that, David, I heard you had a question. Yeah, that's 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 absolutely the argument, right? Like we're going like full force with the argument that it's not only nicer than Barratt Homes, as the company is called, but it's also better for the planet and it is cheaper, right? And it's cheaper. I mean, it's really, you know, if you can, we can build a wall segment in 45 seconds, so that's just game over, right? For someone like this guy, so we can build a factory for £600,000. We can build a factory that can build, you know, houses, whereas they are set in this very old-fashioned, massive factories that are very far from the places where they're building, which results in a lot of labor and a lot of transport costs. So I think it's a no-brainer. Like I think it will be beaten. The main thing that is preventing us from going faster is, I mean, one thing is this war in Russia that is causing a lot of problems with funding, right? The other thing is really kind of technical complex issues around insurance and legislation and a kind of a mind shift of developers who have been doing something, and it's always risky. If you want to build something, there's a risk, and they know that with the known actors on the market that the risk is known, and with us we are dangerous and risky, right? So it's about kind of being able to, yeah, I think a kind of a slow start where you need to demonstrate it, that it works, that they exist, scale 1 to 1, and then hopefully we can roll them out on a larger scale. Yeah. Yeah. Mm. That's Walter Gropius and Waxman's. Yeah. But I mean, we're already. I mean, we're on the market with this thing, so we're past the prototypes. Like we're actually delivering on a small scale, like the small units. And generally, no, in Britain there's no funding. Like that's the sad part. I mean, we're now getting some help from Innovate UK, like debt funding. So I mean, we need to pay it back, but that's one avenue. But in terms of research funding for this, we've fought for it for years, and it's not happening. So we're going now through. We're getting funding now from venture capital. Unfortunately, like that's where it comes from. Yeah. I mean, it's interesting that all the cases I have studied of architects doing this have always failed. So I mean, yeah, but at the same time, you need to be optimistic, right? Like if we can't do this as architects, like we're no longer relevant, right? I think at least you need to have the optimism to dream that we can do it, and it, yeah. I mean, it's very very difficult. It might fail, like it might, but at least we can try it, right? So. Beers?